Hey guys, so we're just going to do one problem here for H11. It's going to be number 2 from the practice. And so here it is. Given the function here, determine all intervals on which f is both increasing and concave up. Okay, so we want to use calculus to do this. And first, let me review with you some things. Okay. So here let's just review Susan's table. All right, let's also review this little this little side version. So f has a critical number if f prime equals 0 or is undefined. F has a relative max or a local max, different than an absolute max. If f prime changes from positive to negative, a local min on f would mean that f prime changes from negative to positive. Okay, so there's that. But this stuff will be more relevant to what we're about to do. So f is increasing if f prime is positive. F's decreasing if f prime is negative. F has an extrema if f prime experiences a sign change. And then, does this repeat? And then these three are these three, okay? So f concave up means f prime is increasing. F concave down, f prime is decreasing. A point of inflection on f would correspond to an extrema on f prime. Now for f double prime, these first three aren't relevant. But then these three, if f prime is increasing, f double prime is positive, decreasing negative, extrema, sign, change. Okay, so there's just a little review. We need to know all of that. And then we're going to do this problem. Okay, so we want this function f. We want to find all intervals where it is both decreasing and concave up. All right, so we want f to be both decreasing and concave up. So whenever you're making these determinations, guys, you want to think about signs, positive or negative, okay? So f decreasing would mean f prime negative. Okay, decreasing, so we want f prime to be less than 0. But then concave up, what would be a sign, positive or negative, that would indicate concave up on f? So f would be concave up if f double prime was positive, all right? Also, if f prime is increasing, but we're looking to do a sign test. So positive or negative is what we're looking for to decide whether, f has certain characteristics. So this would be f double prime greater than 0. Okay, so we're going to find f prime. 3x squared plus. Okay, we're going to, factor it in order to find the critical numbers. Or the critical numbers are where f prime is 0 or undefined. So I can take out a 3. 72 divided by 3. 24. Okay, so 3x plus 4, x plus 6. Okay, so for my f prime number line, I'm going to have, my critical numbers are going to be -4 and -6. We'll have -6 here, -4. Okay, because if you set this equal to 0, then you get -6 and -4. All right, now let's do f double prime. All right, so I am taking the derivative of f prime, which is right here. So that's 6x plus 30. And then let me factor that. X plus 5 And if I think about when that equals 0 on my f double prime line, I'm just going to have -5 there. Okay, now I need highlighters. I got 2 pink ones. Here's a blue one. Okay. So let's do sign tests on f prime. So a number over here would be like -7, -5, 0. Okay. If you plug -7 in up here, 3 is a positive number always. Okay. And then this would be negative, and then that would be negative. So this whole interval is positive. -5. 3 is always positive, negative, positive. So that's negative. 0. Always positive, positive, positive. So positive. All right. So where f prime is less than 0, that is going to be right there, that interval. Now over here, so let me take some testing points. So like 0 would be over here, -6. All right, that's always positive. -6 in here would give us negative. So positive, negative, positive. Okay, and then for concave up, we need that. So it would be here. Okay, now I'm going to put these both on the same number line. So we've got -6, -5, and -4. All right, I'm looking for where the blue and the pink overlap. So we've got, all right, so this is where f is decreasing. Uh-oh. No, I messed up. Okay. So this, whoopsie, those are open. So that is where f is decreasing. And then this is where f is concave up. Now, I sort of messed up when I was drawing this, but this is an open circle here, guys, okay? So we're going to actually have like a union of 2 intervals. So from here to here, oh no, actually that's it, duh. Okay, so where the pink and the blue overlap is where f is both decreasing and concave up. So the answer is, so I'll say f decreasing and concave up on this interval -5 to -4. So this is just like the last phase. Okay, so if you're confused at all, just look at the last phase. The last phase, I gave you the 2 number lines and then asked you a question like this. Okay, this time you're having to take the first and second derivatives, generate the number lines, and then go from there. Okay, but only this is the new stuff. Okay, everything down here was on the last phase.